Welcome to clickmyproject.com. Let me discuss about the project segment-based anomaly detection with approximated sample covariance matrix in wireless sensor networks. Let me discuss about the abstract of the project. Network behavior anomaly detection provides one approach to network security threat detection. It is complementary technology to systems that detect security threats based on packet signatures. In this process, propose new approach for handling segmentation, that is, take neighboring data segments as random variables, then implement the prediction variance detector in order to determine the predictabilities and the spatial analysis to optimize the covariance matrix by Spearman rank correlation coefficient and compression techniques. This proposed approach detects a wide range of long-term anomalies efficiently. Network behavior anomaly detection is continuous monitoring of a network for unusual events or trends. NBAD is an integral part of a network behavior analysis, which offers security in addition to that provided by traditional anti-threat applications such as firewalls, intrusion detection systems. The development of anomaly detection techniques suitable for WSN is therefore regarded as an essential research area, which will enable WSNs to be much more secure and reliable. The algorithm developed for anomaly detection have to be consider the inherent limitation of sensor networks in their design so that the energy consumption in energy nodes is minimized and the lifetime of the network is maximized. The communication overhead by clustering the sensor measurements and merging clusters before sending the description of the clusters to the other nodes. Then detect the anomaly by statistical quantity and estimated the threshold value by chi-squared distribution. This process has been implemented by the data set of the IBRL, also referred to as outliers, expectation, peculiarity, surprise, etc. Anomalies translate to significant real-life entities. Cyber intrusion, credit card fraud, motivated to identify the anomalies by computing the minimum estimate variance of each data sector with respect to the rest. The statistical measure is updated in real time to track the dynamics of the extents. Each MN is allowed to conduct the compressed various sequence and sample standard deviation equivalent to its local data segment. Let me discuss about the flow diagram for our process. First, sensors are deployed randomly in the coverage area which we have mentioned earlier. In the cluster formation, energy optimized cluster formation for a set of randomly scattered wireless sensors. Sensors within a cluster are expected to be communicating with the cluster head only. Cluster head summarize the process and sensor data from the clusters and maintain the link with the base station. The clustering is driven by the minimization of energy for all the sensors. The least energy nodes are formed as subordinate chains or clusters for sensing the data and high energy nodes as cluster head for communicating to the base station. A number of cluster formation protocols have been proposed recently. However, most existing protocols assume begin environments and are vulnerable to attacks for malicious nodes. In this paper, we propose a secure distributed cluster formation protocol to organize sensor networks into mutually disjoint cliques. A cluster first formed and secure and distributed cluster formation protocol by exchanging information with L-hop neighbors. Normal sensor nodes are divided into mutually disjoint cliques in which all sensor nodes can directly communicate with each other. Our protocol guarantees that all the normal nodes in each clique agree on the same clique membership even under the attacks from both external and internal malicious nodes. Next, the covariance matrix are estimated by the prediction variance detector. The prediction variance is an estimate of an interval in which future observation will fall with a certain probability given what has already been observed. Prediction intervals are often used in regression analysis. Given a sample from a normal distribution whose parameters are unknown, it is possible to give prediction intervals in the frequent sense, and one may call these predicted confidence intervals. For a distribution with unknown parameters, a direct approach to prediction is to estimate the parameters and then use the associated guaranteed function. Next, the covariances matrix are approximated by the Spearman's rank correlation coefficients. The Spearman rank correlation coefficient is the sample covariance matrix, is the simplest unbiased estimator and can be easily acquired by centralized approach. The sample covariance matrix is approximated according to the concept of Spearman's rank correlation coefficients. The Spearman rank order correlation is the non-parametric version of the Pearson product moment correlation. A monotonic relationship is an important underlying assumption of the Spearman rank order correlation. It is also important to recognize the assumption of monotonic relationship is less restrictive than a linear relationship, an assumption that has to be met by Pearson product moment. One of the most employed multivariate statistical techniques, reduction of data dimensionality, is heavily based on the behavior of largest eigenvalues of the sample covariance matrix. The reduction can be achieved by undoing the orthogonal variance maximizing direction in the space obtaining the data. Let me discuss about the running procedure for our process. Select the main.m file in the current folder, right-click the file and run for executing this process. This is the main window of the segment-based difference recognition with estimated sample covariance matrix in wireless sensor systems. By pressing the sensor node creation, it automatically created based on the x and y coordinates which I have mentioned in the text.txt file. Next, by pressing the cluster formation, it performs the cluster head selection process. It automatically selects the cluster head based on the distance between the each sensor nodes and also formed the cluster. Next, by pressing the prediction variance button, we can perform the prediction variance detector. It provides the covariance matrix for among 54 sensors. It provides 54 cross 54 values for all sensor nodes based on the covariance matrix. By pressing the Spearman rank correlation button, it performs the Spearman rank correlation algorithm. It provides the approximated coefficient for the all estimated the covariance matrix. It detects the anomaly sensor based on the approximated covariance matrix. This black color sensor denotes the anomaly sensor. This red color denotes the cluster head. Other green color denotes the normal sensor nodes. This is the Spearman rank correlation approximated values for among 54 sensors. Next, by pressing the analysis graph button, we perform the ROC curve for the sample covariance matrix, that is receiver operative characteristics curve between false positive rate and true positive rate. Finally, achieve the greatly reduced computational cost. The prediction discrepancy is now derived from a linear estimator. Thank you.